Good day. Today we're looking at applications of right triangles. These applications are word problems based on the real world. Now, anytime we have this type of problem, it is my very big recommendation to draw the picture to represent this scenario of whatever the problem is. So I'm going to do a couple of these and let you try the rest. Number one. A 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. So I have a building. And I have a ladder leaning against it. It says it is 20 foot long and it is 8 feet away. What is the ladder's angle of elevation? It's asking me about this angle. Now, this is a right triangle because the angle of the building with the ground will be a right angle. I'm using Sakatoa, or some old hippie caught another hippie tripping on acid. These trig ratios for a right triangle. In this one, I have the adjacent side and the hypotenuse, so I'm using cosine. Cosine of my angle, that I don't know, I'm looking for it, is equal to adjacent over hypotenuse. To get rid of the cosine, I take the arc cosine. I'm going to simplify this down to 2/5 just because I like it that way. You can type that in Desmos, ensure you are in degree mode, and you get about 66.4 degrees. Finished. You can pause it, try number 2 and 3. I'll show you the answers at the end of the video. Here's number 4. From the top of a lighthouse is 210 feet high. The angle of depression of a boat is 27 degrees. Now, I'm looking down from the top of this lighthouse. It is not saying that the angle formed there is 27 degrees. If I was to extend a line, it is saying that the angle of depression from this line is 27 degrees. So to find this angle that I need to set up my property, my ratio, is 90 minus 27 degrees for that angle of depression. This is a 63 degree angle. All right, find the distance from the boat to the foot of the lighthouse. I'm looking for this distance. I have the opposite. Here's my right angle. I have the opposite and the adjacent. I'm using tangent of 63 degrees is equal to question mark over 210. When you type this in, you will get approximately 412.1. Make sure you include that unit, which is feet. Try these, and I'm going to look at number 7. A person at one end of a 230-foot bridge spots the river's edge directly below the opposite end of the bridge and finds the angle of depression to be 57 degrees. How far below the bridge is the river? I'm looking for that altitude. So I'm going to be using opposite over adjacent again. Here is my right angle. Tangent of 57 equals opposite is question mark over my adjacent 230. When you solve this, you're going to get question mark is approximately 354.2 feet. Try number 8. And let's go look at number 9. A radio tower 200 feet high casts a shadow 75 feet long. What is the angle of elevation of the sun? Now I have a tower. That'll work. That's my radio tower. And I know it's going to cast a 75-foot shadow. It is 200 feet high, and it says, what is the angle of elevation of the sun? Now, when you first look at this problem, that might be confusing. Where is the sun coming from? Well, think about a shadow. The shadow is based on where the sun is in the sky to your location. So to make this shadow, the sun is going to have to be somewhere up here. That is a sun, not a flower. If you follow this down, it would hit the antenna, and that is what forms the shadow. I have a right angle here. I am looking for this angle of elevation. There's my equation I need to set up. And I'm going to get approximately 69.4 degrees. You can try number 10 and 12 and 13. I'm going to do 11 and 14, and we'll be done for the lesson portion. You can read all that if you want. I'm going to pull out the important information. From the top of this cliff to the bottom is an angle of elevation of 70 degrees. So this entire angle is 70 degrees. To this smaller ledge of the cliff is 55 degrees. How far is the person stranded from the top of the cliff? So I'm looking for the x value. Well, I want you to notice x is equal to the total distance minus the bottom distance, w. Using this, I can find my answer. If we look at the total length y, I have a degree of 70. I'm looking for the opposite side, and I have the adjacent side. This is tangent of 70 degrees is equal to y over 1,000. This means y is equal to 1,000 times tangent of 70. The lower cliff ledge, tangent of 55, is equal to the opposite w over 1,000. And therefore, w is 1,000 tangent of 55. Because I have both of these, I can put them into my formula on the left and solve for x. Now, for the sake of room here, I'm going to pull out the GCF of 1,000, and this is tangent of 70 minus tangent of 55. Whenever you type this in your calculator, you're going to get the distance he is from the top of the cliff is approximately 1,319.3 feet. Try 12. Try 13. And let's look at number 14. Okay, the instruments on this ship detect a large object on the seafloor. The angle of depression is 29 degrees. So I have this right triangle. The angle of depression is 29 degrees. A direct line distance between the ship and the object is about 1,400 feet. About how far below the surface of the water is the object, and how far must the ship travel? So, how far does the ship travel? I'm going to call this unit star. And how far below the surface of the water, I'm going to call T. You just need two variables. I really don't care what you use. All right. I have opposite over hypotenuse and adjacent over hypotenuse. I'm using sine and cosine. To find the length of the depth, I need to use my sine function. Sine of 29 degrees is equal to my depth over 1,400. Therefore, T will be approximately 678.7 feet. Yep, feet deep. My traveling distance is the cosine of 29 is equal to my star over 1,400. The ship needs to travel approximately 1,224.5 feet to get directly above it. Okay, pause the video, try the ones we did not do. Here's the answer key. I do not have them circled. It'll be the last thing with the unit. All right, that is all that I have for you today. Have a great rest of your day.